When sketching a graph of a quadratic, so this is getting you ready for grade 12. I basically rewrote this to make sure that your guys are ready for grade 12. Because the way grade 11 applied is usually taught, it somewhat touches on a lot of things that you need for grade 12, but in a lot of ways it doesn't. It completely, like a lot of terms you're not familiar with. So that's why I made this booklet, because the textbook kind of doesn't do justice, okay? So when sketching a graph within a context, so if it's a word problem, you must label the axes with words and units, okay? So you can't just go X and Y anymore. You have to go, what is X in this case? Oh, it's time. What is it measured in? Seconds, minutes, hours. So it needs to have a variable and a unit attached to it. Just like before, we're going to find the vertex. If we want to find the intercepts, this will give you a good idea what scale to use when asked to graph. Most of the time, variables will need to be positive. Most of the time, variables are positive, which means that the majority of the graphs will be restricted to quadrant 1. Okay? And so here's one example. So you're given the equation h of t is equal to negative 4.9 t squared plus 17t plus 2. What, right? What does that mean? H of t represents the height in feet, and t represents the time in seconds. Now, I will say this, not in general, always for us in applied. Whatever is on this side of the equation is what we consider our x variable. That's where our x variable is found. And whatever is on this side is our y variable. Every time, if I give you an equation. So, when it tells you what each letter represents, t represents time in seconds, right? So we used to call every point on a graph xy. Every point had a coordinate xy. Now I want you to think of it as x represents t, t represents time, correct? So I want you to think of it as time, and y represents the height. So every single point, when you find a point, the first number will tell you what time it is, and the second one will tell you the height in this particular case. Okay, so let's label this. This would be time, seconds. This would be height in feet. You've labeled it, good. You see these points here? This would be our y-intercept. This would be the vertex. This would be the x-intercept. Normally, okay? The y-intercept is always 0 followed by a number. 0 is a number too, Mr. Dirksen. I know. I hope you know what I mean. It's like whatever that number is, that goes in there, but the 0 is fixed. For the x-intercept, the x is always 0, and the other value will be, sorry. Mr. Dirksen, wake up. I'm too excited. Hold on. Take a deep breath. It's number followed by 0, because y is 0 here, right? You haven't gone up or down. Okay, vertex, I will just go, it's x and y. Now the y-intercept will be, we call it in this context, would be the initial height. Okay, this is the often what we're going to refer to this as the initial height. The vertex in this case will give me the max height, which is going to be y, after x seconds. So here you will find the maximum height, which is going to be determined by the y value, right, after x number of seconds. Okay? And this one right here, in this context, will be time for object to hit the ground. Another way to refer to this is remains airborne. And if anybody's taking physics, you're going to probably recognize some of the things that we're going to talk about. Maybe you're not there yet, but at some point you will. So again, the intercepts and the vertex are still very important to us, but remember we're now down to the first quadrant only. Do not go arrows out of it, because that's going to change everything. So a little intro as to how things are going to change in terms of wording. Next, domain and range. Domain and range changes here, guys. It's no longer, okay? Note, none of this stuff, okay? None of this infinity nonsense, okay? There could be, I'm not saying there will never be, but for now, forget about it, okay? No infinities, because it stops. We were talking about real world scenarios where things stop to move, okay? And so for the domain, set notation, interval notation would be the x values you're interested in. Set notation will go as follows. It'd be 0, okay? Yeah, here, this is the one. In this case, I have to use the letter t, because t is the x variable here. And it would be the greatest x. So your domain is from time 0 till the greatest x. The greatest x value in this case would be when it hits the ground. So you'd have to figure out how long did it take to hit the ground. Interval notation for domain, by the way, both of these would get a d in front of it, like with a colon like that. We would go from 0 to greatest x. Square brackets. That's in general. For the range, we're into the y values. So for range, we use squiggly brackets, remember? We go from, this you have to be careful, lowest y value, h, greatest. Lowest y to greatest y. And you have to use the letter h because h represents the y variable. If you want interval notation, you would simply go lowest y to greatest y. I would say this is study sheet. This is study sheet entry. I will box this whole thing in. And I may, from time to time, give you a little cheat for this down the road, but for now, this is where it's at. So let's practice this. We'll do a few concrete examples so that you can wrap your head around this domain and range nonsense. Okay? Let's keep going. if there are, a test could easily have 3 to 4 domain and range questions. That's 3 to 4 marks. So out of 40, that could be 10% of your mark. So you need to make sure you practice this. So for this first one, state the domain and range. Let's do the domain, let's do interval, and then we'll do set next. And I'm going to break this down here. So we'll do the domain, and we'll do the range. I'll use 2 different colors here if you want to follow along. I will use pink and green. That's what I'm going to use. So for my domain, I'm going to use pink. So you want to kind of go to the x-axis and see, is there a graph to be seen either above me or below me? And it is, right? It starts right here. Keep traveling along the x-axis. I still see a graph. I still see a graph. And then at 450, it stops. So you're basically going from 0 to 450. Okay, so for interval notation, you would simply say that the x values that are acceptable in this case goes from 0 all the way to 450. Remember, 0 to the greatest x value possible, and the greatest x value is 450. For the range, it changes. We're going to go on the y-axis. Does it start at 0? Is 0 acceptable? Yes, it does touch 0 here, right? And it seems to be touching 0 there. So you keep going until you don't see a graph anymore. And so right there, that's when you stop seeing a graph along the y-axis. So go to your graph and say, in terms of the y, it starts at 0, and it goes as high as 50,000. You see that? That's the 50,000 mark in terms of the y values. And that's, yeah, 50,000. So for range, we would go, it goes from 0 to 50,000. Boom, you got your range. I love interval notation. It's so much easier for me. So I tend to answer in interval most of the time. But we got to go set as well. I can't just let you off the hook. So 0, basically the variable for x, I'm going to use L. Let's use L. Let's assume it's L in this case. So length is between 0 and 450. So you just do one of these. That looks like a, there we go. Between 0 and 450, and same with range. You just go 0. What letter should we give y here? I'm going to give it A for area, because on the y-axis you see area. So I'm going to go area, and it's 50,000. The numbers are going to get big. Don't fear it. You have a calculator. Calculator can help you with it. Okay. All right. I want you to practice this. So if you don't mind, like I'm going to zoom out here for a bit. If you wouldn't mind just making this line go right to the bottom. Right to the bottom. And for on the left side, it's going to be interval. On the right side, it's going to be set. So you can go domain and range for the second graph, and then you go domain and range for the third, and domain and range for the fourth. figure out what is the lowest x value in this story and what is the highest x value. Look at your domain first. Then look at your range. Maybe don't highlight yet. I will go over it. But I need you to just write something down. This is almost like I'm just testing the waters here. Testing the waters. Like how comfortable are you with this? Are you completely missing it, or are you kind of getting there? Do I just need to address some of the misconceptions? So give all of these a try. Everything on this page, you should have seen domain and range before. If you haven't, just give this a try. Okay. One second. Oh, Alan, are you still copying? There you go. I think I have some 0.7, but it's not the greatest quality. It breaks. I think most are actually done, or you're getting there. I want to actually get to word problems. Ooh, I was recording this whole time. I wasn't swearing or anything, so. Okay, so for the domain on this first one here, you're going from 0, the graph goes 0 all the way to 17. Okay, so we go from 0, x is 0, all the way to the largest, which is 17. So this is how you would want to write it. For the range, you go all the way to 0. At some point, even though you don't start there, you do end up at 0. So 0 all the way to the highest point, which is 18. So you go from 0 to 18 there. That is your range there. I will rewrite them all in a bit. For now, I'm just going to stick with the interval. For this one, again, your domain, you start at 0. Look, 0 is a permissible value. It just happens to, like, think of a submarine launching a missile or rocket or something, right? So you're under here and it launches it and it goes and then it hits some target above ground. So think about it this way, but you do start at 0 and you end at 10. So all of these values all the way from 0 to 10 are permissible because you can see a graph, right? So this would be 0 to 10. Range. You go all the way from -20 from here all the way to +3. Okay, so all of this is acceptable. So this would get you to 3. So it's negative 20 to 3. You got to make sure the order is like this, smallest, largest. Last one. You ready for this one? Make sure you follow. You go from 0 all the way to 4.5. Okay, so the domain is usually not the hardest to figure out. It's the range that is harder, in my opinion. So for range, the lowest you ever get to is right here, 13. And the highest value you ever get to in this scenario is 32. So it is from 13 to 32 that your range exists. Okay? And there you have it. Maybe for time's sake, I'll rewrite some, like this one, for example. I'll go 0 times 10, like this. And this is negative 20 H3. Okay, so you have that one there. This one would be 0 T 4.5. And this one would be 13 H32. Okay, so that's how you do it. Oh, I should have asked you to do the one on 34. I made a new one. You're the first group that sees that one, I think. 34, at the top, this is your AC for right now. You're not going to have to hand that in. But 34 at the top, what's the domain and range of something like that? Interval, set and interval, so we'll do both. So for the range, we go from 0.18 all the way to 3.45. This one is here to trick you, but it's not the highest. The highest is 3.45, right? So 0.18, 3.45. And so for our set notation, there it is. We've got it taken care of. All right. Keep going. I'm going to pass on this for now. So we'll skip this for now because we can just enter it into our calculator and figure it out from there. 36. Are you laughing because of what I said? Okay, inside joke. Got it. The equation was provided, so we'll start with this one. Make sure you have your calculator ready for this. The path of a baseball being hit can be modeled by the following equation. H of t is negative 4.9 t squared plus 35t plus 4. I'll actually start a brand new video here. I'm just going to talk about